Okay.
We're live on YouTube now.
Yeah, we are live on YouTube now. Let me check. There is no resonance and all, right?
But microphone is also that laptop. So whoever is speaking has to come.
Yeah, we are live on YouTube now.
That stream you have to mute.
There is no resonance and all, right?
Other window. No, not here. Other window where YouTube is running. Maybe microphone is also that laptop. So whoever is speaking has to come.
Okay, so let me call.
Share the live stream link in the WhatsApp.
Joy, I guess you can switch on the lights in the model. So it's coming dark.
Switch on.
All the lights.
But it's glare.
Oh.
You have to let somebody. Everybody has the presenter permission. Hi, Saptarshi.
Hi, you can hear me?
Can
you
you
hear me?
Your face is a bit dark, so
Yeah, so I'll have to adjust the light.
Or you can face the light.
Yeah, just one minute.
yeah, sure. That light is clear.
I hope it's better now.
Yes, sir.
Yeah, much better.
Okay. All right. So let me, bring out the PPT that I want to share.
Volume.
So we are going to, I am going to present some of the works that we are doing in Calcutta University Data Science Lab on the area of solar energy forecasting. Okay, so three methods or three attempts that we have made is what I will like to touch upon today. Okay, so let me just on the screen. Okay, so
Soundbar.
Okay, so can you see my screen?
Not yet.
Is my screen visible?
Not yet.
Not yet.
Not yet.
Still coming from the laptop.
No.
Somebody want to join.
Okay, let me try again. Okay, somehow it is saying it is paused. I don't know why. Yeah, it says your screen sharing is paused.
I think you can choose the audio in Zoom. Here the mute.
Let me try again.
Samsung.
So let me try again. Sorry. Oh.
Yeah, we can say it now.
Okay.
Okay.
Okay. So first of all, let me thank Mass Research Club for organizing these masters, and not only that, building this ecosystem across the nation. Okay, connecting data scientists, academicians, people from industry. Okay, so probably I can go on the initiatives that are being taken, but let us not spend time on that today. So as I was mentioning, I would like to discuss about some of the solar energy forecasting techniques where we are applying deep learning. So let me go right into the topic. So it goes without saying that solar energy is one of the most important constituents of clean and renewable energy. So the total power generation that is happening, 28% of that is renewable, and out of them 85% are from wind and solar. So essentially we are working on both solar and wind, but today's discussion will limit to solar energy. Okay. And one of the problems of solar energy is that you cannot store it. Okay, so if you want to really integrate with other sources of energy, right, so you actually need a fairly accurate forecasting system. Okay, not only that, there are also some regulatory mechanisms by which the solar power stations also need to submit their estimate. Okay, and if they are beyond certain error, okay, so they can be charged penalty. So there are, for Indian context, there are even more reasons why you need a forecasting in solar energy. Now uh, like briefly, probably know how it works, right? So it will typically, the solar energy will typically come to the photovoltaic cells, and then you get power as out. Okay. Now there are many other things that goes into place, getting the actual power output from the sensors, and then maybe the quality of the reflectors that are there, or amount of amount of pollution is there, and so on and so forth. Okay, so for that, what we do is we from the research world try to predict something called as global horizontal irradiance. Okay, which you can think as a proxy of the solar power out. And at a high level, this is how the GHI looks like. So GHI is essentially at a particular area, how much solar radiation you are receiving. Now you can receive solar radiation in two ways. One is through the direct radiation, okay, which is called as direct normal irradiance, or DNI, and the other is by some diffusion. So that can happen from refraction, okay, or it can be diffused from the clouds, right? And that entire thing, so the diffused horizontal irradiance and direct normal irradiance, right, this makes the global horizontal irradiance. Which, so if a particular area, okay, is getting certain amount of GHI, that can be used to understand at one side the potential as a solar energy station. So that can be useful even before you are going and setting up a solar plant. And second one is, of course, in terms of forecasting. Okay. So if we try to quickly, look at the taxonomy of the forecasting, right? So you can, from approach point of view, you can classify it as statistical and machine learning model, and then deep learning approaches. So essentially, there are more approaches, right? There are physical models, okay, which are called as NWP models, numerical weather prediction models, okay, which are governed by atmospheric equations, okay. But there are certain issues with those kind of models, which let me not put into the today's scope now. Okay, so that approaches we are not discussing here. And then in terms of forecasting window also, I mean, it can be very short-term forecasting, right? So very short-term is in hours, short-term can be in days. And then there is also medium-term forecasting, long-term forecasting and all. But here what we have tried to emphasize is the problem that is critical from Indian context. Okay. And model type, it can be univariate or multivariate. So we can just take the previous GHI values as input, okay, and try to predict. Or if it is multivariate, we can combine other features like humidity and etc. Right? Okay. So let me. So these are the models that I was talking about. So if you are looking at physical models, these are NWP. Statistical models are ARIMA and GARCH. So both are like important statistical models. You can have machine learning models, okay, which are like random forest, boosting, etc. And then you can have deep learning based models like recurrent neural networks, long short-term memory, gated recurrent unit. Okay? And as I was saying, so maybe based on the forecasting window, if it is within certain hours, it is very short term, and short term, if it is more than that, you call it a short term. Okay. So let me just give you a quick overview of what goes on here. What goes on here, and you see, you have so RNN. RNN. What happens is, it is how it is different from traditional neural network is it is suited for sequence tasks, right? So where the current current output is dependent on previous few time series. So happens all around us in time series, in natural language modeling, and so on and so forth. Okay, so that's where you use recurrent neural networks. So where there is a connection, as you see, there is a connection that is being made. Now, recurrent neural networks actually can be fairly long, and as a result of which you come across a very common problem of deep neural networks, which is called as vanishing gradient problem. So, which is somewhat solved by LSTM and GRU, and it also brings in another feature. So, what happens is that so I will just try to give an example. So, let's say I'm trying to predict the output at October 23rd, okay, and when we are trying to predict October 23rd, of course, October 28th, October 21st, October 22, 22nd is very important, okay. So this is the short-term dependency when we are trying to predict something, but there is also a long-term dependency, which is that previous year's October can also have an effect here, right? So these kind of dependencies are very difficult to handle when you are looking at any traditional network or even RNN. So LSTM GRUs by some kind of a gated capabilities, okay, have this characteristics to learn both short-term and long-term. Now LSTM actually have different gated components which represents long-term memory and short-term memory. Whereas in gated recurrent unit, this becomes you have less number of elements, which combines kind of long-term and short-term memory, making the architecture simpler and making it easier to train. Okay. So when you are trying to feed data into LSTM or GRU, okay, so you have to do a input processing of the data, right? So whatever raw time series you have, you cannot just like that put there. So typically you will see that the Keras framework in TensorFlow, okay, so that will take a 3-dimensional input array. Okay, so what are the dimensions? Firstly, the dimensions are that how many time steps you are taking. So let's say you are trying to predict the GHI of 8:15 a.m. So maybe you are taking a 15-minute interval starting from 6 a.m. Okay, so how many observations then you have? You have 8 observations, right? So that's your number of time steps that you are including. Okay. Now, how many number of input features you are taking? So if it is univariate, you are only considering GHI. You have only one input feature. However, you can have humidity and other stuffs, right? When it can temperature, the cloud formation. So all this can be included in a multivariate setting. And as far as number of samples are concerned, so you know that typically we like to train our neural network in a batch gradient descent mode. So this tells you how many batches are there when you are doing it for training or using it for training. And it is not very different from a traditional neural network setting. Only thing is that instead of the neural instead of your perceptrons, okay, coupled with activation functions, you are using LSTM. Okay, so that's the basic difference. So we were interested to see how LSTM can apply in this area, and there were not much research when we started was available here. Okay, so when we are when we are surfing the research articles, the blogs, and different other artifacts, we saw that one of the things about deep learning, is that it is good for a raw time series, right? You don't need to do any pre-processing. Okay, so but we saw that when people are approaching this problem, some of them are applying pre-processing, some of them are not applying pre-processing. So it was not giving a clear direction. So what we did was, we set up the experiment like this, that we trained the LSTM both with raw data and pre-processed data. Okay, and what we found out was that actually you do not need to do much of pre-processing, okay, when you are training LSTM. Having said that, just after a couple of slides, I might contradict with this, but that is your usual take. Okay, if you have some intuitions, you can definitely go ahead and apply that. Okay, so this is what we find out, that it doesn't need any pre-processing. Okay, and also very interestingly, and you might find it surprising, that some of them were treating it as a non-time series problem. So you have different time steps, right? So what people were doing it, they were treating them as different features. So lag 15 is one feature, lag 30 is one feature, lag 45 is another feature, like that. And we also wanted to check that whether indeed that is the case. Okay, and we set up in non-time series and time series mode, and you can see that when we have set it up in a time series mode, our performance measured in terms of normalized RMSE has gone down. Okay, and all the experiments you'll see that we had to do for multiple solar stations, because every solar station has some uniqueness that following different climatic zones, and also different seasons. Even for the same station, the performance varies, right? Okay, so now also one question that came to our mind is how many nodes. So we generally get very carried away in making our neural networks complex, right? So we think that, okay, if we go on adding nodes, our performance will improve, right? So it turned out that there is a relationship between the variability, like how much variable, how much uncertain that station's GHI values are, with the number of nodes that we are taking. So we could see that for Chennai winter season, Howrah winter season, Ajmer winter season, we are having a less variability, and with 50 LSTM nodes, we are getting optimal result. Okay. However, if you see Howrah, rainy season of Howrah and rainy season of Ajmer, they had a relatively high variability or high uncertainty. And as a result, you can see we almost needed double the nodes. Okay, we needed 100 nodes there. So if you want to read more about this, so this is the paper top page. Okay, came in Springer Nature Applied Science. So you can go through the entire experiment. Okay, so now another work where we were thinking that can actually feature engineering help in deep learning. So this is where I was saying that I'm going to contradict. Okay, So essentially, you know that when you have neural networks, right? So they are actually learning representation, okay, at a very high level. So you have input and you have output, and there are hidden layers in between. So what these hidden layers are doing, they are learning better and better representation of the data, so that the end task happens in a better way, right? So that's the reason, convolutional neural networks are so successful, because you don't need to extract handcrafted features by yourself, right? Like hog features or some gradient features and so on and so forth. Okay, so our thinking was that traditional ML was rich in feature engineering techniques, right? So can we use some intuition and input? Okay, so I will not use it blindly, but let's say I know some features are good. So can I try a mix and match approach? Okay, so now the model that we chose for experiment is bidirectional GLU. So many of you know that here what happened is that there is a forward GLU and there's a backward GLU, and you take the same time series, you train from one side, and the same sequence you just reverse it and train from the backward side. Okay, very useful when you are doing missing word imputation in natural language model. So please understand, if you have some missing words and you have the past context, the words just coming before it, as well as the words that are going to come after the word. So if you have both this context, your prediction becomes much more better. Okay, so our intuition is that if I give bidirectional feature to bidirectional model, it will be giving better result. Okay. However, I would like to mention that current state of the art is that you take a sequence, you feed it from forward sequence, reverse it and forward it from backward sequence. So that's what happened. So this is what we wanted to change. So however, you know that for time series, I don't have future data, right? So what we thought is that why not take some previous day's data. Okay, so let's say I want to predict 8 a.m. data, okay, from both forward and backward direction. So let's say I take the forward data 8:15 to 9:15 data, or even 8 a.m. data also from yesterday. So can it help? Okay, so that's the experiment that we set up here. And one of the things that I would like to point out here is that over different climatic zones. So you see these box plots actually represent different models performance. Okay, so all these are representing NRMSE of that particular model. Okay, and if you see our model, which is bidirectional BGRU, okay, so bidirectional GRU coupled with our bidirectional model, you will see that indeed our MSC NRMSE is coming very, very low. Okay, so this intuition really works well. Okay, that if you give a bidirectional feature, and you can understand that there are many other ways to augment it, but this is just a step that we have taken. Okay, so if you want to read more about this paper, so this is the paper, paper front page that I have given you for easy reference. Now, one other challenge that we saw, quite often is that, so all these models, okay, are very, very dependent on local weather. Okay, so the model that I am building for Ajmer is not going to work for Howrah. You can understand that. That's the first thing. Also, the model that you can build for Ajmer winter season is not going to work for rainy season. So one of the things that we understood is that so many models, so model maintenance is itself going to be a challenge, apart from training those models and wasting so much of resources and so on and so forth. So we thought that why not use transfer model over here? Okay, a transfer learning over here, right? That we have a network, okay, which is pre-trained, and then so I mean, if you look at the GHI, right, it will be only having non-zero values during the day. It will have a certain kind of seasonality. So all these things are common, but maybe the variability is only different from each other. Same type of math problem, but maybe the complexity is different, right? So maybe it is for grade 1 schools, maybe it's for grade B schools, and something like that. So we thought we'll apply transfer learning, okay. And one of the challenges that we faced was that, okay, that in transfer learning you need to select a base model, okay, or base station where you are going to train your basic model. So which solar station will choose for that? Okay, so here what we did was, again, we thought that let's look at the variability each of the stations have. Okay, so it's like saying that, if you have a lot of students, okay, and the students that get exposed to the most complex mathematical problems, okay, will learn the concepts better. So that's the intuition we follow. Okay, so we saw that this Guntur station in the month of August, this has the highest standard deviation in terms of GHI. So this standard deviation we again used as a proxy, okay, to mark the complex maths problem analogy that I'm telling. Okay, so we took it as a base model and then we tried to train it, and you'll be surprised to see that this actually gave better result than the individual BGRUs if you have trained them on those particular stations. Okay, very interestingly, this is what came out and all the cases. Okay, now also another advantage that we saw was in terms of training time, where you can see that across the board there is around 70% reduction in training time, and of course there will be also reduction in number of parameters. Okay, because in transfer learning, that the initial layers you have fixed parameters and then you have trainable parameters, so number of parameters also gets reduced. Okay, again a quick comparison in terms of box plot, okay, across climatic zones, and you can clearly again find out that our transfer learning based BGRU gives the lowest MSE and also the lowest variability. So the lowest, like the bias is low as well as the variance is low. Okay, so you can read more about this in this particular paper. So front page again for your easy reference. Okay, so the last slide, last one approach, and I will not go take you through the slide. So I will just try to give you the intuition. Okay, so the intuition is like this, that so far what we are doing is we are treating, one station as a logical unit. Okay, so we are building a model. So we are building a model for Ajmer Renaissance. Okay, so that's the grain on which we are developing the model. But the thing is that the weather can really be variable. So it can be rainy in the morning, and then you have some kind of a dry weather, sunny weather. Again you have rain. Okay, so how do you actually combine this, or how do you tackle this? So what we did was we actually now tried to cluster the different times series into different clusters. Okay, so we can find out, okay, this is a rainy cluster, this is a hybrid one where there is a mixture, and then you have a dry cluster. Okay, we can very easily find that out. So we call it as a global profile because we collected these data points from all the stations, combined them, and then did the cluster. So now we have 3 clusters, and what we did was we trained different LSTM for different clusters. Okay, so I have now 3 LSTM trained. So when the prediction time comes, I find out in terms of its observation characteristics. So is it a dry condition? Is it a wind? Is it a cloudy condition, or is it a hybrid condition? As we can find out, we pick that specific LSTM for prediction and do our job. So these also gave us quite a lot of improvement. Okay, I'm not sure if I have put, yeah. So if you want to read more about this paper, so this is the front page of that. Okay, so that kind of summarizes some of the works that we have done. So we are doing some more. Okay, but let me not take more time on this topic, and we can probably discuss this further. And if you have time for take questions, I can take that now. If you want to connect offline, you are more than welcome. You have all my coordinates with you.
Thank you, Saptarshi. Yeah, we'll open for questions. So if anybody has questions, you can ask. Just come a little closer to ask the question.
Saptarshi,
Hi.
can you hear me? Am I audible?
Yeah,
Yes.
you're audible. Go ahead.
Yes, Shaptashida, this is Debraj.
Hi, Devra.
Yes, just one question that in
Yes.
case of multivariate time series,
Mhm.
what are the different variables considered? Means after we that LSTM is done, so we will receive some multivariate information. So we will we will go for an average or
I'm not able to completely follow you, Debraj. I'm not sure if people out there, Srijak and all, can follow. For
No,
me,
Debraj,
the
you're
voice
breaking
is.
up. You're breaking up.
Yes.
So if you can just repeat.
just what I'm asking that when we apply for a multivariate time series. So in multivariate time series, the variable that we consider at the end of the time series, are we taking an average of that or some new features is being created from there?
I still could not follow completely, but we have done something on multivariate, okay, and multivariate also, as I said, is you will take it as another time series. That's all, okay. So you tell them as exogenous time series, right?
Okay.
So you don't take average value, of course. You take the entire time series. Only problem is they can be in different not time grain, okay. So for that you may have to apply some interpolation or filling out the data and etc. So we have that's a good question because we also have done something on multivariate forecasting. Okay, so we also have a paper on that, but we didn't bring that up here. Okay, if you're interested, I will share that with you. Yeah.
Sure. Thank you, Shaptashida. Thank you.
Yeah. Any other thing? Okay, all right, then I think there are no further questions. So thanks once again to the organizers, and all the best for today being a fantastic event, and for more such endeavors. So I'll just log off then. Joy has
Yeah,
logged.
uh, just thought of having one query. Is it okay if I can ask?
Yeah, it's, you can come closer.
That's right. You can hear, I guess. Are you able to hear me?
Yes.
Yeah. So that's a great work actually. Congrats on that attempt and whatever you have covered. Thank you for sharing with us. At what stage is this? Is it like going to get implemented? You're going to do something like that, or it requires more
Yeah.
work?
So we are working with National Institute of Wind Energy (NIWE), which is a autonomous body under Ministry of Renewable Energy. Okay.
Okay.
So all this data are actually the data are given by them. They also have a data analytics team. So the models that we are giving them, they are trying to implement and see if they can improve the forecasting. Okay, so right now our collaboration is limited to NIWE, but we are also having some collaboration with NICR, which is an a similar organization from United States. So they actually have also done this clustered based techniques. Okay, so we do not directly go to industry. Okay, but through these bodies, we are trying to implement these models. So they have also shared some other problems, especially on the wind forecasting side. Okay, so maybe when we come up with some good models there, we can share that.
Awesome. Thank you so much. And one last thing. So once
Yes.
this kind of thing gets implemented, or any stakeholder, government or whoever starts consuming it, using it, what are the at least two benefits that we can think of straight away that anyone can get through this implementation?
I could not follow your question completely, but I could follow some of the keywords. Okay, so yeah, so in terms of benefits, see, first benefit that we need to give is the reduction of the forecasting error. Okay, because this is still a challenge. If you look at current literature, our margin of error from the current forecasting methods is not really very good. Okay, so we are doing very detailed. So this is, you can understand. So this is 3 years work. So it is not something we have started, right today. So we are trying to go into the anomaly conditions. Okay, that where our prediction is going haywire. Okay, because I can report an average error, right? So like we are not making an error on normal instances, but whenever there is a change somewhere, we are making a lot of error. But in average, the error is looking promising, okay, or good. So we are doing a lot of study like that, and some of the stations, okay. I think Kota Vida is one of the areas where NIW has particularly asked for our help, because none of the forecasting models work there. So that's the first benefit. And second ancillary benefit is, of course, in terms of, as I said, that sleeker model maintenance becomes easier. So you don't have to use so much of resources. So right now, the state of the art they're using 58 models, and then they're doing an ensemble of it. Okay, and you can understand that for so many solar stations they're running that. Okay, so they have now increased their GPU size and so on and so forth. But if we can bring their more efficient models, that also is one of the benefits for them.
Okay.
So if there is no
Yeah,
question.
thank you, Dr. Sri. Yeah, if there is no question, we can go to next one.
Okay.
Thank
Okay,
you.
thanks guys.
Yeah, thank you.
I'll just sign off there. All the best for rest of the event, and rest
Thank you,
of your
David.
endeavors. Thank you, Joy.
So I request Tanishto to, so we have like the next discussion is around like on the creativity and artificial intelligence. So we will have a panel discussion, and we are just setting up the panel here. So be with us. Okay. So Tony, over to you. And can you hear us properly?
Yes, I can hear you properly. Can you hear me?
Yes.
Perfect. Okay,
One
great.
second, Tanya. One second, Tanya. I'm just
Yeah.
checking. Yeah, we are all good.
Perfect. Great, thank you. And I think I would start with welcoming Anubhav to must. We've been having these sessions for a while. We didn't have anybody who's permanently with us because we have all been shooting in and out. Anubhav, it's great that you've joined the team, and welcome. I hope you're enjoying yourself.
Thank you. Thank you so much.
Perfect. Great. So we will see some great stuff coming out from Anubhav in the coming months. So today, in terms of Grandmaster, it's great to see everybody at the Must office. And I think this is the first time that we are having a panel discussion where all the panelists are sitting in one room, right? We have mostly been having it virtual. Uh, the topic that we thought of is something, because Must is a place where a lot of technical topics get discussed on a regular basis between all your esteemed scientists that we have. But outside this world, right? Outside this world, and I would just like to introduce myself that my background is business. I am into marketing, and I've been there for a while, right? So I've been in marketing for quite some time. And one of the things that I do on a regular basis is actually talk to creatives, creative teams, creative directors, creative people who are mostly into art and advertising, music, mostly art, and they are the ones who actually express this concern. And the the panel discussion that we are having actually came out of some real concerns that I was having when this OpenAI released DALI 2, right? So me being an AI enthusiast, I obviously sent the link to everybody saying, take a look at the beta. It's fun. You can create, designs like real surrealistic art based on texts, right? So when I was sending it, a lot of the creative guys came to me and said, Tony, what does this say for our future? Do we need artists? Are artists going to get obsolete? Do people really need art when AI starts creating these kind of stuff? Because some of the DALI 2 is really, really, out of the world. So that kind of prompted this debate. And I thought I'll come back to Joy and use Grandmaster, as a forum to see how is AI going to impact creative expressions, right? It's not just art, even though the concern literally came from the artists first. But so this was a fantastic opportunity to kind of connect with all of you and get some of the doubts cleared in terms of, is AI a threat to creativity? Is AI a collaborator to creativity? And to start off with, let me just start by a question that's being asked to Joy. So, Joy, this is specifically for you, uh, and and give a very free and frank answer to this. How good is AI? Because we know AI has made a lot of development, but it has not always been what we thought it would be sometimes. So, how good is AI in free flowing creative expressions like creating social media conversations or creating paintings or images? Where are we?
Yeah, certainly. It's a very good question. So, first of all, when we talk about AI, right, we actually try to understand different kind of patterns, right? So that's the first important thing, right? So whether it is a style of writing or it's a kind of painting or cartoon, right? So any graphics or piece of text, right? We first the algorithm should try to learn the pattern. Just the way we understand, like, Acha, this is a painting by, say, Monet or Van Gogh, right? Now, how we identify as a human being, even if it is, suppose we have seen like 10 different paintings of Van Gogh, then a 11th one comes, and I have seen like some other artists' creativity as well, but I can identify that 11th painting by Van Gogh as Van Gogh's painting, right? So now, because of the patterns. Now there are a lot of artists who also follow Van Gogh's pattern, right? So they are also trying to paint their or create some piece of art which is in Van Gogh style. Now, as a human being, if I see that, right, sometimes I may also think about like, okay, this is probably Van Gogh's painting. The same way, suppose if I studied, have probably a lot of literature from Shakespeare, and then I'm trying to write English in that pattern, right? Because every author or the painter or artist, right, they do have their own patterns. Now, using AI, right, where it helps here, for an example, it can be helpful for creative ideas. I think you have seen there are a lot of tools, even in Microsoft PowerPoint, right? You have
Right.
design, right? So, and design thinking, user experience, all these things are kind of a hybrid of science and technology and art. That's very important, right? So AI is helping us in like design thinking, automatically generating some of the best combinations of, say, foreground color and background color and what would be the best graphics and so on. So at the same time, it's not a threat. I don't think like AI should start painting like Van Gogh. Anyway, if one human also starts painting like Van Gogh, I cannot say like that's the Van Gogh's original painting. The same way, I mean, even if someone tries like to create like an algorithm or write an algorithm which will start, right, I mean, writing prose or poetry or drama using AI, that won't replace any human being, or that won't be, it will be all fun, nothing else, right? It's not a threat. At the same time, on a positive note, right, if we start thinking about this conversational AI, which is playing a major role in this field, right? So whether it is through social media, whether it's a chatbot and just a railway reservation ticket versus a banking, online banking transaction, right? Those things can also be done where the natural language generation will play a major role. And then the graphics, if you have seen the Mask website, right, the pencil
Right.
sketches, those are generated by adversarial network. So it is a program generated pencil sketch. So I don't think that's like a trade, definitely. Right? So it's fun. At the same time, we are leveraging a lot of like automatically generation of piece of text or image or video, and definitely the design or the user experience. That would be, I think, a great help from the AI side.
Okay, now that you just mentioned conversational AI, let me come to the next point. Right, one of the things that we've been trying to use AI for is actually social media conversations. It has got two different aspects. One is pure fun, as you said, right? A fashion brand or maybe a tech brand often tries to create AI virtual influencers. We have heard of some AI virtual influencers coming up. And the second thing, at a very base level, every organization is trying to reduce their efforts in terms of the regular social media support that they give to their customers, right? So when customers have grievances, they reach out. That's the easiest thing to reach out to, right? Just tag somebody on Twitter and say that, my phone is not working, my network is down, I hate the way you bill me. So these are very common grievances that people have. And one of the ways to counter them is actually addressing or having a chatbot answer these questions, right? And at the same time, most organizations are trying to go beyond answering simple questions, and they want their AI to actually create humorous content, have fun while on social media. And we all know that social media conversations die within a very short time. If somebody is not keeping the conversation going, it is going to die. But how many humans are going to be employed to keep a conversation going 24 hours, and across multiple countries? Because that's what happens, because most organizations have gone global. People are buying from all over the world, and therefore it is important that they are talking to someone. So the next question is that, when you implement such AI in terms of having regular social media conversations, and when you train them, what are the chances that they are going to go rogue? And when I say rogue, I don't mean like sentient AI. I basically mean that they are learning from what the other people are having in terms of conversations in social media. And we all know that biased, racist, these kind of conversations are very common in social media, right? If you're dark, you get castigated on. If you are from a particular community, you get castigated on. So what are the chances that the AI is going to also get biased or rogue in such instances?
Anyone wants to answer this
So
question?
here's a classic example, right?
Recently, I think Facebook.
Yeah, Anurag, you can come. Please come in the front.
Recently, Facebook released a conversational report wherein it was asked that what is their opinion, like the board's opinion of Mark Zuckerberg, and the first time it said really good things, the second time it said really bad things about him. So it was kind of mixed. So I feel it's more about while we are while it is scraping through the data to formulate a training set, right? If we can identify those biases, right, and then try to eliminate them, and if we have a cleaner training set, it might be easier to discard any of these. But it is not very obvious to prevent this. So this is likely to happen to some extent.
The natural flow of it.
Okay, any more opinions on this? Because I know this is a very hot topic. People would like to hear about it.
So this is actually not the first time this has happened with Facebook.
Right.
Correctly, around 2020, I believe, they launched the chatbot for the first time. I think within 3 days, so they made it open basically for all the Facebook users online who are trying to have converse with it. It seems within a week or something, like most of the people tried to misuse it, right? So the way they were talking, it tried to learn. So within a span of a week, it tried to abuse everyone who is who chatbot is talking.
Yeah, so it's just like again learning from patterns, right? So the risk
Right.
is once it is open and live and it is trying to learn from the patterns of the text or language which is being used by the other users. So what we can do, right, to enhance the algorithm, we can actually think about like to reduce those kind of like words. So if that is being spoken, then we should not learn that, right? The algorithm should not learn that. So those kind of things can be also done using AI only. like kind of a content moderation. We are actually working on a project on live content moderation, whether it is video, whether someone is
Any digital content.
digital content. It can be like spoken language, it can be body gesture, it can be images, like the emotion. So all these things together, it's a multimodal information retrieval and then responding back, right? So we are trying to moderate the content itself. So that is also another interesting project in AI to just avoid this kind
Right.
of situation. Because there was another Twitter handle 5-6 years back. It happened with Microsoft. So that is called TA, right? And then the same thing happened. Like it was an automated Twitter handle, but it started like learning from some racist comment and sexist comments and all, and then started tweeting on behalf of. So again, it had to be shut down immediately. But the thing is, like from these learnings, right, we can improve the system in such a way, like there should be like moderation as well. Sometimes human aided moderation, sometimes totally automatic.
So you can use it as a wrapper or a layer on top of that.
So quick question. We have had this lots of talk about, and since you mentioned training, right? One is that if I can moderate when the AI is already on, that is when it is live, and if it learning from there. The other thing that we've been hearing a lot about in the recent times is synthetic data. So do you think by using synthetic data, or synthetic data actually has a future in terms of training conversational AIs like this?
So synthetic data has pros and cons, right? So one thing is like synthetic data, if it is made by human, right, then those kind of data can also have like some bias, right? It may be biased
Right.
data. The positive point is, yeah, definitely we can have like high volume of data once we collect like real data. It's a like lot of effort are required. At the same time, if we have synthetic data, sometimes the training model is easier. But the problem is like if that data is like biased towards a particular region or a geography or like anything, right? So it can happen with multiple parameters where the synthetic data can be, right? So that's another problem. So an example is speech technology. And suppose we are thinking about like a conversational AI which will speak in Hindi. Okay. Now, if we apply like synthetic data, that means we are using like again a robotic speech which would be used, right? Now, for that particular speaker or the synthetic data of the speech portion, right? Those will be a particular type of it. So, and that Hindi, if it is from UP, right, that may not match with Bihar or may not match with Madhya Pradesh or the Hindi spoken in Hyderabad, right? So, that's very important, right? So, if we have to collect data, then we have to also remove all these biases, include all the varieties. But sometimes what happens, we miss out those varieties or the the previous discussion also when Saptarshi was talking about rainfall also, right? But rainfall in different region matters, and they differ. In the same way, like the model will also learn a different way, right? So that's again important. So what kind of context we are using for synthetic data, that's very important. And sometimes again it happens like once we generate the data itself, it gets like replicated, same kind of similar kind of. So ultimately the model can become like overfitted with respect to like high accuracy, but it will start failing in the inference stage.
So, so when you say synthetic data, and this in this particular context, what you said is that just very, very relevant in terms of, when I'm having conversations, that is where context becomes like supreme, right? What is contextual in UP or acceptable in UP might not be acceptable in West Bengal or in the South, right? So that's how it is. What about other forms of art? Let's say paintings or things like, let's say, advertising and marketing copy, or maybe just plain film script. Film script is still contextual, but let's say something else. And where do you see AI going and playing a role? Because we have seen how chatbots operate, and they have become quite mainstream now. uh, we have just started to see something to do with art. But where you do think that places like music or advertising or films, where do you think AI is going to take a key role, and why?
See, I mean, any creative, anyone wants to answer this question?
You do.
Okay, so my point is like, so design ideas, right? Anything on the idea side, AI can help, right? So AI, we are not expecting like the AI algorithm will generate the painting, but sometimes we also will get confused like, okay, this is the context, and now I am say a creative artist and working in a corporate, right? And now I have to create an advertisement for that, right? Say a poster. This is a simple poster. So if I know the context, right, and what is the product and the solution or the service being offered in that particular advertisements, then AI can give me a lot of ideas, combinations and combinations of ideas with that, the scenarios, which is probably I couldn't think, but I got the idea from that. So that is one area which in my opinion, others with that points, AI can play a major role. But at the same time, we are not expecting the entire creativity will come, right? So it will be like a lot of combinations and ideas.
Yeah, one more thing to add is like, say you are ideating about advertisement idea, right? So you have a couple of ideas going on in your head, but you can't visualize. So likely you pointed the DALI tool, where you can pitch a text idea to it, and it can give you a visual representation from which you can get inspired, or from which you can take inspiration and build your whole advertisement campaign from that idea.
Or you can put it in front of others in a better way for them
Yes,
to connect with it.
yes. Like you have an idea, you are not able to explain to another person through this DALI tool. You can visualize the idea and show it to somebody to better reciprocate what the idea is. So that way, I think it can help.
Also talking in terms of the scenario and the creativity. No, that's fine.
Also, we can't see you. We can't see you. The screen needs to see you.
Okay, I mean, hi. So
Yeah,
talking because AI itself wouldn't do anything, but AI using AI, many people can develop or create or establish a lot of scenarios, for example. So think it of it as like today we are in the age of multiverse. So let's say n parameters. So as a human being, I think we can only be limited to thinking at a creative level. Means if I think of a particular scenario, let's say Britannia, I have to create an ad and a particular scenario of Amul. All the scenarios that I can think of and he can think of, I think there can be only a substantial overlap. There will be one segment which will be purely in, and there will be another few multiverses of creativity or something which can come out of that different inputs if you give, which where the human limitations can come, but the AI as such, they can create, and if you train across different things. So, we can think of developing an engine like that, which can a creativity engine or stuff like that. So we can feed it with all the different types of scenarios and all the different types of ads and worldwide, all the things that have been happening with different localities, locales, scenarios, context and all. And it can, so I'm just giving an analogy to what's happening in terms of music creation, in terms of art creation and all. But it cannot replicate. I mean, exact same idea, it might not come up. So when we talk of the thread as such,
right.
like I can imagine as Van Gogh or something example, like the pastel, the color, the crayons, and all that thing that person would be using, and the output that you will be getting, vis-a-vis the same exact thing. So if I take a photo of Van Gogh's painting and an image delivered by AI engine, can look maybe 95% and more overlap. But if I'm a consumer, if I am someone connoisseur of an art, then would I be able to, if I'm paying let's say $100 for this, would I pay even $50 for that? That's a big question. So that thing can never be replicated, how. So similar way, certain notes and stuff which you might do with a music, it differs from field and field industry to industry. But since you mentioned film industry and a lot of things, advertisement and all, so just a small analogy toward that. Like my take.
Very interesting that you said that, because as we know, the creative industry works in very different ways based on what they're creating, right? Now, if it is an individual artist, he's mostly focused on his own paintings and murals and all that go up on the wall and kind of are sold individually. So it's a one-to-one relation between a buyer and a creator, right? But when it comes to things like films and all, that's where a big team works, right? So there is a script writer, there is a storyboard artist, and then comes the musicians and the directors and production. And we all know what VFX is doing to the world of films, right? Where about 80% of the film is actually made in CGI, right? So there's that's also AI at work in some way, particularly when it comes to VFX tools and all. But I do buy your point that, if I could actually generate multiple versions of a storyboard, it would really help the film director visualize, particular scenes or particular actions in a much easy way. And it's definitely time consuming when it is done by a human, right? So overall, the film industry benefits. Question is, how do the creatives benefit individually from it, right? Because if the storyboard artist actually has very little job in creating the storyboards because it's built in AI, then what does the storyboard artist do afterwards, right? And that's where the question of livelihood, or the question of, are creatives, should creatives be threatened? Because that's what creatives think, right? We think in a very different way. So that's where the question is really coming from. And that brings me to another point, is that, okay, if AI is supposed to kind of help you think better, then how should people collaborate with AI? Because that's, or how should they think about AI or collaborating with AI to actually make a difference, to feel that feeling of threat should go away? How do you think creative artists should look at AI, rather than the way they look at AI now, oftentimes, as that, my paintings are getting replicated, everything is being done by machines, am I going to lose my job? So that's
This
beyond that.
this kind of question is, I think, very akin to what we faced with the Y2K bug, right? Before
Right,
the computer coming into India, I know you can connect better in the eastern sides of the country. There have been ransacks and stuff when computer got installed, desktops and all of lakhs and high values got ransacked, broken, and there were protests that there's going to be labor unrest and unemployment, blah blah blah, right? But what did IT or technology did? It enhanced. It helped you move ahead, do things better, optimize better in whichever field of life. So just taking the example of a storyboard writer, if I'm a storyboard, what I can imagine, I'm not from that film in the other industry, so I'm not an
right,
expert, but yeah, I can whatever I can talk in the scenario. So if the director wants any यार scene ऐसे चाहिए, थोड़ा ऐसा और क्या हो सकता है? So probably as a human mind, I, with my background, with my experience, with my talent or my notion, whatever, the way I view life and all, I can probably come up with only a n number of series, right? But if there is something more, like probably if a Rajamouli does what a Subhash guy or a Karan Johar does a particular, that it cannot, still there will be a lot of scenarios and stuff left, right? Which
right,
probably the provide you. So when you as a storyboard writer, you can think of and stuff. This kind of a validation machine or something you can check up more, check up. So it's an assistance. It's not actually going and creating the
Recommendation.
yeah, it's a recommendation. It's not actually, see, even you spoke of AI, VFX and all. We saw Avengers, we saw Bahubali and RR.
right,
See, we don't see it for the VFX only. I mean, of course, but that's 50%. We see also for the person who's playing the role and all. And there, like, what's the name of the person? Been Fast and Furious? Who died? Paul,
Aaron Paul.
Paul Walker.
Yeah,
So
Paul Walker.
last Paul Walker. So the last scene after his death, which was shooted through an AI positioned image of Paul Walker, when the end of the scene, that doesn't give that look and charm of the thing of which actual Paul Walker would have given. So it's of
Right,
course not the 100%. So if you now make an entire film on Paul Walker or for that Chadwick Boseman,
right,
Black Panther is not showcasing, it's only a few glimpses and all. So again, talking of that, the person who's actually the actor or the actual music director or the content or the singer or whatever, the actual people who are actually doing it. So AI comes as an assistance, or like how when before IT era, before computer coming in, right? It came in and assisted in a lot of things. But smartphones came and assisting our lives in numerous ways. But I don't think that is actually, doing the thing for us in life. It's a tool. You need to use a tool, not like the tool replaces you.
Actually, I want to give an example. So, like couple of years back, I was working with a friend, and she is a director in Doordarshan.
Right.
So she has a couple of serials in Doordarshan, and at that point of time, she was working with the Doordarshan that was being launched in Arunachal Pradesh. So we were working in Delhi, and actually I was just like, hanging out with her, doing my job while she was directing all her series and everything. So one fine day, she had a lot of work, and she handed me a script, and she was like, "This is the script," and so basically, for people who don't know. A director is also the assistant director is also supposed to like collate, like look at the scene and figure out that okay, we need these many objects. This is the this is the attire the protagonist is going to wear. This is all what we need for the scene, and they have to collate everything together in one place, and then probably give the boy who's working on the set to arrange everything so that she has they have a visual of what is going to happen in the scene, and probably enact the scene and figure out this is what the changes are going to be, or this is the changes we want to see in the scene. This is not what we exactly wanted. So that whole process of collating all the objects and what all you require in the scene, they have to go and procure it and everything. But before that, the script itself is like 800 to 1000 pages, and she has
Right.
to go every scene, every part of that scene, and collate all the objects and write that this is an evening scene. This is these are the objects required in this scene. This is the placement of this object in the scene, and this is the location. That's a cumbersome process, and she would probably, the assistant director would spend like per scene, around 40 minutes to 1 hour just to collate everything. So these kind of things is where AI can come in and automate all of these actions that are being done by humans. It's a very simple thing, but of course,
Right.
when we actually think about it, think about automation, think about also like okay, we are automating it, we are running some sort of natural language processing, grouping all the objects that are alike, grouping it together, location specific wise and all of that. Then after that, we can have an intelligent system where you can actually, you don't have to go to the actual location and set up everything together, but you can actually have a visual representation of it on your screen and do all the changes there. It's like, okay, this is what I want, this is not what I want, I can change it here itself. So you are actually eliminating a lot of human work, effort, and time. You are saving time.
So basically, what you're doing is you are ensuring that the people who are part of the set, they focus on the important part, right? The procuring part, rather than not spend time on the listing part. That what do we have in the script? I think this is a brilliant example of how films, for example, can be done. Okay, any other examples that anybody else has? I think this was brilliant. This is absolutely brilliant.
Shall we can talk about video analytics? You can come over here.
I think you should. I think you should. Video analytics is going to be a very critical part of you know
Yes,
a lot
so
of
actually,
industries.
creator, and I was doing a project recently, a research project on digital marketing on consumers. So I noticed that there's a lot of psychological or let's say AI inclusion on where we're doing when a video specifically on video marketing, when you
Motion
have
pictures.
motion picture actually. So when a consumer is targeted, there's a lot of thought on how one particular, let's say, how a consumer is going to react to the video, well,
Right.
advertisement, the ad. So to analyze how a consumer is going to react, the AI inclusion of how they're going to, let's say, how do I take this example? Can you give me a moment to think about it?
Sure,
Maybe
sure,
I don't have
absolutely.
kitchen, so I'll just
Maybe you can take example of festival times. How they are
yes.
targeting.
So in festival times, before, and they'll target a specific target audience. For example, in Diwali, there'll be a lot of advertisements on diyas or sweets or let's say gifts specifically. So to identify these let's say target products, there's a lot of let's say previous surveys or previous analysis that is done using AI models to come down to or to consolidate this list of products that is being produced rather than just campaigning on various products that shows high potential sales but are not that much required to be campaigned about.
Same case goes with the Christmas and December season as well. They emphasize on colors, the red color and green color
Right.
and white. It's a kind of emotions. We are kind of playing with the emotions, making them conversions to the particular product or ad. And her main project includes about the motions, how the video is affecting the targeted customers, how they are increasing the sales in perspective manner.
Yeah. So I believe that there's a lot of let's say previous analysis that is done to run let's say AI model on arriving to a conclusion. I'd like to add into a point that was being discussed before that AI would replace a worker or not. I'm not that experienced on it, but I do believe that jobs are being created and being lost as it's a long term that would be noticed that equal amount of jobs are being created compared to that are being replaced. So it's just a short term illusion that we face that there's a lot of loss of jobs because of automation and AI models. But all in all, it's just assisting us. It's something that helps us create more opportunities rather than losing out on job opportunities.
Perfect. I think those were some of the perfect answers I heard. Definitely that use case is like immensely helpful. And more than this conversation, I think it's a way to go back for me to my the people I meet and the kind of questions they raise. And my answer is always, let me go back to the researchers in Must and See. Right? That's the traditional answer I have. I said, okay, I don't have an answer to that, but let me go back to Must. I have a think tank that I can always ask, right? Which brings to another point, when I said creativity and how patterns are helping, and how, let's say, what Dorito just said, in terms of how Paul Walker got replicated. That brings to the question of deep fakes, right? We've been hearing a lot about deep fakes. We can see a deep fake. If you go to Bored Humans, there is a scene from a 1950s movie called Gaslight with Melania Trump and Donald Trump in that, right? So they have replicated the first couple of scenes with Donald Trump and Melania Trump as well. So now the question is, deep fakes are turning out to be a threat. And what do you guys think should be, because we know it's being used in pornography, it's being used in vilifying other people. I mean, we have seen a lot of deepfakes coming out of Obama himself, right? So what do you guys think should be a way to counter that? Is there a way to counter because human mind is always going in all directions, right? So there's always a chance that there's could be a lot of people who will be using deepfakes for nefarious purposes. But how do you really counter it with technology? Is there a way to counter it with technology, or should we just leave it?
So I would like to answer this. So let's just look at the architecture of how a deepfake is created. So a deepfake is basically generated by adversarial network.
Right.
So what that network does, it actually checks whether the generated image is quite similar to the actual data. Now, I feel there should be an adversarial network just to identify whether it is a synthetic image of a person or it is actually real. So we can train on that itself. And obviously, the ethical side of AI. So a person who is just entering into the data science and AI field should always be preached from the very beginning that this can be a threat to lots of things. So the ethics is a big thing which should be preached in a very elementary stuff. So basically, when I was introduced to computer science, I was taught about ethics and computing, like
Right.
governance basically. So
the ethics part out here is very important, and obviously there should be some adversary again, just to to validate that whether it is a generated one or like a original one. Like there is a classic example of this in Spider-Man 3, most probably the old Tobey Maguire one, where the other reporter actually creates a fake image of Spider-Man just to defame him. So that was basically done in all these image editing tools. Now using AI, it can be done by any person. The codes are available in GitHub, so it can be done. There's just the internet connection in your laptop is like what you need to do that. So there should be some there should be some adversary, what I told right now. Like now we can understand this image is fake image or Photoshop image, which we call the morphed images. So there should be some development in this field of understanding which is a morphed image and which is not. So basically Musk is also going to work on something on morphed images, where people are morphing this insurance documents and claiming false insurances. So all these are Photoshop documents. So there should be some processes, like there should be some research on this. So the two parts I would like to summarize. One is preaching ethics from the very beginning, and then to work on the research of understanding deepfakes.
That has multiple applications.
Yeah, there are multiple applications. Because not only the faces of deepfakes, there can be anything. A person, a car, a bike, anything.
Right.
People can just create a video of car getting crashed and claim insurance. See, this is my car. This got it accidentally. I broke the car and things like that. So there should be some research on understanding this, which is.
But technologically, it's possible, right, Anubhav? Yeah, technologically, it's possible to kind of counter it.
Because you see, every image which we click right now, each image is getting tagged on our phone at which location it is clicked, the exit details, like what is the pixel, what is the megapixels, the metadata of every image. So what happens is now, if we share the image via mail, all the metadata is stored, but as we send it through WhatsApp, it is compressed and all the background data is erased. So there should be some strict laws, like you should not be deleting the background details of the images, the geotags, the zoom info and things like that. So once we validate that yes, this is a image which has been taken from this so and so camera at so and so point, then yeah, it is we can validate that yeah, this is a real image from a camera and not one which is generated. And also this metadata should also be implemented in the GANs and the new technologies, where there should be a metadata behind the generated videos or generated images.
Architecture.
Yeah, the architecture should be tuned like that. So here the major part is to preserve the metadata and also to create a metadata for our synthetic data.
Right. This is perfect. I think I got a lot of the answers that I was looking for. And at an overall level, when we look at the newspapers, and that's what most people do, right? You guys are into the depth of it, but for the rest, it's all the hype that the newspapers create. When DALL-E 2 came and everybody said that, newspapers said, okay, our creative is going to be replaced, and then all the creatives started calling that, hey, you did some articles on AI. Can you just explain? Our job's a threat. I said, I'll find out. Right. But do you really think that in the last 2 to 3 years, where we thought AI would go in terms of supporting or accelerating creativity or any such conversational AI, do you think it is gone where it was supposed to go, or do you think there's it's actually gone slow over the last couple of years?
We have expected in 2000 or maybe in the 90s, and in 2020 we'll have flying cars.
Right.
Expectation having is very exponential to the growth we are having. Okay. So there are a few things which we need to understand out here in part of development of AI. First thing is, what is AI? Is there a clear answer to everyone? Does everyone know what is AI?
Right.
there's a fan here in the Musk lab. Okay. So this fan is Wi-Fi enabled. People are calling this an AI fan. But is it an AI fan? It is just an automated fan using IoT devices.
Right.
If the fan can understand that yes, I'm feeling hot and it starts, on its own, then that is AI. When you start detecting people are feeling hot and now I can switch on myself. That is AI. But not this. Yeah, emotional. But not this, which is just an operated machine I can operate with my phone using the Wi-Fi. Okay. So understanding what is AI is the big thing. So AI is still a very hypothetical concept to people. Artificial intelligence, ye ho jayega, wo ho jayega. It's not that. It's not that. It is just data put together and the output we can see. And we are training a machine to, understand how can we achieve this output from that input. So that is basically what is AI is. To understand how a specific output can be generated from a specific input. So two things are there. People are not really ready for AI because at a very basic level they don't understand what is AI. Second thing, we don't have a specific set of data. We have lots of data, lots and lots of data, but actual segregation and actual usage of data is not there. Required data.
Right.
Yeah, the data basically. The relevance is not there of it. Like we start with a problem. We are given terabytes of data. Are they really relevant? We don't know. We take time in just understanding which data should we use and which data to discard. So maybe the big thing, and we are as data scientists and AI engineers, we are lazy. We don't spend time in data collection. We find, are there any open source? Let's use it. Accuracy, baad mein dekhenge. Let's just build the model. So the major part is the specific data collection is very important. Spending a time, in collecting data will give you a better, result with AI.
Consuming the data.
Consuming data. So the quality of data is important. So lack of quality data is also a thing which is, a hindrance to the spread of AI.
Right.
And then infrastructure is there. The infrastructure, the AI hardware we require is very costly. So that is also another thing. So a layman cannot use AI. Like if I maybe as a bachelor student, someone wants to implement AI, he will not have that hardware. He'll go to his parents and say, I want a GPU. So Papa bolega, you will play games, I won't buy you. So things are like that. So a layman cannot directly get their hands dirty on AI. So these are all the things I would like to mention for you. I will have everyone to add on with this.
Yeah, guys, please add on to Anubhav's points.
Sajeev, some words from your side.
Yeah, okay. So basically, one of the points that we started with was that we speculated about flying cars. The reason we speculated about flying cars is that in the 1990s, our imagination was limited, and flying cars were the only thing we could think of.
Right.
And the reason did not materialize is not because flying cars are impossible. Actually, they are very much possible today. But there are so many other things that we want to do more. So we ourselves changed our mind and said, no, we won't do flying cars. We'll do them later and do something more interesting. So typically, that is what happens. That technology may be capable of doing things, but it is the economics which drives what will actually get implemented.
Right.
Yeah. So maybe we can do an artificial general intelligence or come slightly closer to singularity, but who will pay for it?
And what is the usage?
कौन खरीदेगा वो? उसके लिए पैसा कहाँ से आएगा? So even if a big capitalist pays for it, ultimately there has to be a business model around it, and nobody is interested, then it won't happen.
Right.
Actually, technology innovation ultimately goes where the needs of society are. And if the needs of society really were for flying cars, they would happen. But that's not what Janta wants. So even so the artists who are saying कि हमारी नौकरी जाएगी क्या? अगर हमने art का AI बनाया, even if we make an AI which does art, and their job is gone, is somebody going to buy that AI?
Exactly. And is it all that? Is it anywhere close to what a real art provides?
Yeah, I mean, for example, we can get an instrument from Yamaha probably or Casio, which will get the perfect Shruti. But can it replace Lata Mangeshkar?
Right.
Nobody will buy it. It is just like a tape recorder for them. They will still go to the concert to listen to her. So the artist will never. It can at most augment their productivity. That is what will happen in practice.
Perfect.
To a large extent, I think you can echo on that. I think that level of work that you are saying, the core AI, what Anubhav you mentioned, happens in things like ocean research, NASA and stuff, where the things are really relevant and the data is consumed, cleared, strategized, and bifurcated. And there those things find actual relevance. But those are very few, probably 2-3% of the entire world of application of AI, data science, whatever you call it.
Yeah, environment or climate research, there is some need of society being fulfilled. So then it will happen. But just something fancy for the sake of being fancy, people will abandon the idea once they realize that it's not what society
It's
wants.
not what it is used to be. I think we are out of time, but this has been some great answers. Guys, thanks so much, because since we are going YouTube live, and I think the video which is going to remain in YouTube also, right, Joy? So I think this is going to be a very, very relevant video to go back to for a lot of other people who are beyond must, right? Because this is a very, very common question. These are very common questions that I face. And me being part marketing, which is, I deal with AI on a day-to-day basis to a certain extent. But at the same time, not, right? A lot of the work that I do is with creative artists and designers and these kind of people. And yes, my friends do ask me a lot of these questions. So this is a fantastic conversation. Thanks so much, everybody in Must. And I look forward to hosting something similar again very soon on a different topic.
Thank you.
Thank you.
Thank you. Thanks, Tony.
Thanks, Tony.
Thanks so much.
Thanks everyone for joining, and we'll get back again. Bye.